The surface of Venus is 465 degrees Celsius, hot enough to melt lead. The atmospheric pressure is 92 times Earth's, the pressure you would feel at nearly a kilometer beneath the ocean. The clouds are made of sulfuric acid, and it does not rain from them because the surface is far too hot for any liquid to reach it. Rain of sulfuric acid falls from the upper clouds and evaporates in the middle atmosphere, 25 kilometers above the ground. This is the closest thing to hell that exists in our solar system. And yet, there is a serious and growing body of scientific work that argues Venus was not always like this. That for as much as 3 billion years, longer than complex animal life has existed on Earth, longer than most of the history of the solar system, Venus may have had oceans, rain, a temperate climate, continents, possibly life. I want to be careful about that claim from the start, because it can be told in a way that is misleading. Earth has hosted some form of life for around 3.5 billion years. Venus was probably not habitable longer than Earth has been habitable in that raw sense. The claim is narrower and stranger. It is that Venus may have been habitable for most of its history, while Earth for most of its history hosted only microbes. That for a very long stretch of solar system time, a stretch longer than the entire fossil record of complex life on Earth, two temperate worlds may have existed side by side around the same star, and that one of them went quiet quite recently in cosmic terms, while the other one is still going. This is a video about a possibility that most people don't know is being seriously discussed. It is also a video about the ways we might be wrong about it. To understand the claim that Venus was once habitable, we have to start with what we know about the Venus that exists now and how strange it is. Venus is almost exactly the same size as Earth. Its mass is 82% of Earth's, its diameter is 95% of Earth's, its density is nearly identical. Of all the planets and moons in the solar system, Venus is the one that most closely resembles Earth in the crude physical properties: the size, the mass, the composition of its rocks. It formed at the same time from the same material in the same neighborhood of the solar system. And yet its surface conditions are radically different. The atmosphere is 96% carbon dioxide. The greenhouse effect is so extreme that Venus is hotter than Mercury, despite being nearly twice as far from the Sun. There is essentially no water anywhere on the planet, not in the atmosphere, not on the surface, not, as far as we can tell, in the crust, but the deuterium to hydrogen ratio in the Venusian atmosphere is around 100 to 200 times higher than Earth's, and this is the chemical fingerprint of an ocean's worth of water having been lost to space over geological time. Lighter hydrogen escaped upward, out into space, and left the heavier deuterium behind. The signature of the water that used to be there is still readable in what remains. So we can say with reasonable confidence that Venus once had substantial water, enough to matter, enough to leave a chemical signature when it disappeared. What we cannot say, what nobody yet knows, is what form that water took, how long it lasted, or what the surface of Venus looked like while it was there. The traditional answer, taught for decades, was that Venus was born hot, that its water existed only as vapor in a steam atmosphere, that it never condensed to form oceans, and that the runaway greenhouse effect began within a few 100 million years of formation. In this picture, Venus was never a habitable place. It was born a hell and remained one. The newer answer, which is the subject of this video, is that this picture might be wrong. And there is also a very recent answer, published in 2021, which argues that the traditional picture was right all along for reasons the older work had missed. Three positions, all currently held by serious researchers. The disagreement is live. The case for a long-lived habitable Venus comes primarily from climate modeling, in particular from a series of general circulation model simulations run at NASA's Goddard Institute for Space Studies, published between 2016 and 2020, led by the planetary scientist Michael Way and colleagues. These simulations start from a set of plausible assumptions about early Venus and ask a specific question. Given these initial conditions, could Venus have maintained a stable, temperate climate? Could it have kept liquid water on its surface? For how long? The assumptions matter, so let me name them. The models assume that early Venus rotated at close to its current slow rate. One Venusian day is 243 Earth days, longer than a Venusian year. They assume the early sun was about 30% dimmer than it is now, which is standard in stellar evolution models. They assume Venus started with a modest ocean. The models test different amounts, from a shallow global ocean of about 10 meters up to something closer to Earth's total ocean volume. And they assume the atmospheric composition was more Earth-like than Venus-like at that time, dominated by nitrogen and water vapor rather than carbon dioxide. Under these assumptions, the simulations produce a surprising result. Venus, in the models, is stable. It is temperate. The slow rotation, which sounds like it should be a problem, turns out to be a solution. Because Venus rotates so slowly, its day side heats up over an extremely long period. A Venusian day is over 8 Earth months of continuous sunlight. And this generates thick, persistent water clouds on the sunward side of the planet. These clouds act as a planetary parasol. They reflect enormous amounts of sunlight back into space before it can reach the ground. And they keep the surface cool enough for liquid water to persist. The picture, if these simulations are right, is worth trying to see. A young Venus with an atmosphere thinner than the modern one and dominated by nitrogen. Water clouds, real water clouds, the kind we have on Earth, not sulfuric acid, building up over the day side as the long Venusian day progresses. Below the clouds, oceans, not the small oceans of a marginal case, but real oceans, with waves and coastlines and tides, continents raised above them, tectonically active, weathering under rainfall, a hydrological cycle. Weather, storms. We don't know if life emerged there. We don't know if any of the conditions we now believe were necessary for life on Earth, hydrothermal vents, tidal pools, clay mineral surfaces, were present on early Venus, or how similar their chemistry would have been. But if we are asking whether Venus had the surface conditions in which life could have emerged, the answer given by these models is yes, and for a long time. Depending on the specific assumptions used, the simulations suggest Venus could have maintained surface temperatures between roughly 20 and 50 degrees Celsius. Warm, but well within the range that Earth life tolerates. In the most optimistic model runs, this state could have lasted up to 3 billion years. In more conservative runs, several hundred million. The honest way to describe the result is not Venus was habitable for 3 billion years, but Venus could have been habitable for anywhere from several hundred million years to 3 billion years, depending on which of several plausible starting conditions was correct. Even the low end of that range is substantial. Several hundred million years is roughly the duration of complex animal life on Earth. If it is right, Venus was habitable for a long time. The models also suggest that this stable Venus eventually destabilized, most likely around 700 million years ago, though the date is uncertain and could be anywhere from 300 million to a billion. Something happened, most likely a massive resurfacing event, of the kind that geological evidence shows did occur on Venus at approximately that time, in which large portions of the planet's surface were repaved by volcanic activity. This event released enormous quantities of carbon dioxide, kicked off the runaway greenhouse we see today, and boiled away whatever oceans remained. In this picture, the Venus we see now is the Venus of the last few hundred million years. The Venus of the previous few billion years may have been unrecognizably different. Not a hell, a world. The scenario I've just described is not the consensus view. It is a possibility supported by a specific line of climate modeling, and it is contested by other climate modeling that reaches the opposite conclusion. The strongest recent challenge comes from a 2021 paper by the French planetary scientist Martin Turbet and colleagues, published in Nature. Turbet's team ran their own simulations of early Venus, using different assumptions about cloud microphysics, and produced a very different picture. In their models, early Venus never had oceans at all. The water that was present remained trapped in the atmosphere as vapor, held there by a thick, opaque steam envelope that never allowed the surface to cool enough for condensation to begin. The clouds in these simulations form preferentially on the night side of the planet rather than the day side, the opposite of what the WAY models found. Night side clouds trap heat rather than reflecting it, which produces warming rather than cooling. The picture in Turbet's models is worth trying to see too. A young Venus, hidden under a permanent opaque steam envelope. No sunlight ever reaching the surface. No oceans, ever. The atmosphere itself is the story. Hundreds of bars of water vapor and carbon dioxide glowing in the infrared, radiating outward into space. Below it, a molten or nearly molten surface, hot enough to keep any water that tries to condense from ever reaching the ground. A world that was never blue. A world that skipped the temperate phase entirely and went straight from formation to hell. Two groups of scientists using the same underlying physics, feeding in different assumptions about clouds, have produced two Venuses. One is temperate and blue for 3 billion years. The other is a steam world from formation. Both simulations are competent. Both are published in serious journals. Both are defended by their authors. The disagreement is not about the observational data. There is very little direct observational data about early Venus, because Venus has no preserved ancient surface record for us to sample. The disagreement is about which cloud physics is correct for a hot, thick atmosphere with a slow rotating planet under a young sun. Small changes in assumptions about cloud altitude, cloud droplet size, and cloud response to solar radiation produce enormous changes in the predicted climate. We do not yet know which set of assumptions is right. There are other reasons for caution beyond the cloud disagreement. The WAY models assume Venus rotated slowly early on, as it does now. But some models of the early solar system suggest Venus may have rotated much faster in its youth, and that tidal interactions with its own atmosphere slowed it down over billions of years. If early Venus rotated at Earth-like speeds, the cloud parasol mechanism that keeps the WAY model Venus cool would not have operated. There is also the question of how quickly water was lost. Venus is closer to the Sun than Earth, and water molecules in its upper atmosphere were split into hydrogen and oxygen at higher rates. Some models suggest Venus could have lost an ocean's worth of water within a few 100 million years, regardless of what was happening at the surface. So the honest picture is this. There is a real scientific case that Venus was habitable for as much as 3 billion years. It rests on a specific line of climate modeling that is well motivated and taken seriously in the field. There is also a real scientific case that Venus was never habitable at all, that the current dry hellscape is not a recent development, but essentially the original condition of the planet. Both cases are being actively argued. Neither has won. We have imagined two different planets, and we do not yet know which one existed. We may be able to settle the question in the next decade. 3 new missions to Venus are currently planned or in development. NASA's DAVINCI and VERITAS, and the European Space Agency's EnVision. These missions are designed in part to look for the specific geological and chemical signatures that would distinguish the two histories. If Venus had oceans, it should have sedimentary rocks somewhere in its ancient terrain. It should have chemical signatures in the tesserae, the older elevated regions that some scientists suspect are ancient continental crust. It should have particular ratios in the deuterium and noble gases of its atmosphere. We do not yet have the data to check. We may soon. Let me stay with the way model possibility, though, for a moment longer, because if it turns out to be right, it changes something fundamental about how we think about habitable planets, not just Venus, but the whole idea. The traditional picture treats habitability as a property of a place. A planet is in the habitable zone, or it isn't. A world has liquid water, or it doesn't. Earth is habitable. Venus is not. Mars is not. That's just what these planets are. The habitable zone of our star is drawn as a shell in space, and planets are inside it or outside it, and this determines whether they can host life. But stars evolve. The sun is about 30% brighter now than it was when the solar system formed, and it will continue to brighten as it ages. The habitable zone, in other words, is not static. It moves outward over time. 4 billion years ago, when the sun was dimmer, the habitable zone was closer in than it is now. Venus, which currently sits inside the modern habitable zone's inner edge, would have been comfortably inside the ancient habitable zone. And Earth, which is comfortably inside the current habitable zone, will eventually find itself outside it in roughly 1 billion years, as the sun continues to brighten. What we are looking at, if the way models are right, is not a solar system with one habitable planet and several dead ones. We are looking at a solar system where habitability is a temporary condition, held by different worlds at different times, as their star ages and their surfaces evolve. Venus was well positioned to be habitable when the sun was young. It gradually left the habitable zone, or fell out of a stable state within it as the sun aged. And Earth, which is habitable now, will follow the same path on the same timescale, driven by the same brightening star. Venus is not the sister planet that failed while Earth succeeded. Venus is the sister planet whose habitable period ended earlier, in a solar system whose habitable planets have all been given finite habitable windows by the evolution of their star. If this is right, then somewhere out in the galaxy, there are systems in the opposite configuration, where the outer of 2 rocky worlds is currently habitable, and the inner one has already gone through its warm period and cooled into hell. There are systems where habitability is just now beginning for a world that was too cold before. There are systems where both rocky planets are habitable simultaneously, as ours may have been for a while. The image of habitability we should hold is not a permanent property of a special place, but a phase in a planet's life, opened and closed by the light of its aging star. There is one more thing I want to say about the Venus possibility, and it is the thing I find hardest to hold in my head. If Venus had oceans for 1 billion years, or 2 billion, or 3, then it had sedimentary rocks, rocks laid down by water, containing the chemistry of those oceans. Some of those rocks may have survived the resurfacing 700 million years ago. Some of them may still exist on Venus today, buried under lava flows or preserved in the ancient tesserae that were never resurfaced. If life existed in those oceans, its chemical traces, biosignatures, isotopic ratios, maybe even actual fossil structures, may still be preserved in those rocks, under the acid clouds, under the crushing atmosphere, at the surface temperature that melts lead. There may be a geological record of a lost world. It is not clear that we could reach it. The tesserae are rugged, elevated terrain, difficult to land on, and no lander has ever survived on the Venusian surface for longer than 2 hours. But DAVINCI, if it flies, will drop a probe through the atmosphere and image the surface of a tessera region during descent. It will not land. But it will look, from close range, at rocks that may have been formed in an ocean 4 billion years ago. It will be the first time we have ever done this. I don't know what we will find. Nobody does. That is what makes the question worth asking. Here's the image I want to end on. Somewhere around 4 billion years ago, the solar system had two temperate rocky worlds orbiting a young dim sun. One of them was Earth, the other was Venus. Both had oceans, both had water clouds, both had weather. On one of them, on Earth, and we know this from the geological record, life emerged sometime in the first several 100 million years in the form of single-celled organisms in the oceans. On the other one, on Venus, and we do not know this and may never know it, perhaps something similar happened. Or perhaps not. The chemistry was there. The conditions were there. What actually occurred is behind a curtain we have not yet drawn back. For a long time, perhaps 1 billion years, perhaps 3, both planets remained temperate. Then, on Venus, something shifted. The volcanism may have accelerated. The sun brightened. The clouds thinned or reorganized. And Venus gradually and then suddenly crossed a threshold. Its oceans evaporated. Its atmosphere thickened with carbon dioxide. Its surface heated past the point where water could exist. Around 700 million years ago, give or take, a resurfacing event completed the transformation, and Venus became the world we see now. Earth kept going. Not because Earth was special, but because Earth had certain advantages: plate tectonics, a magnetic field, a slightly greater distance from the Sun, that Venus lacked or lost. Earth's habitable window is still open. It will not stay open forever. The same brightening sun that ended Venus's temperate period is brightening still, and in something like 1 billion years, Earth will reach the point Venus reached, and its own oceans will begin to evaporate. The Venus we see is not a planet that was born wrong. It is, if the newer view is right, a planet whose habitable period ended before ours did, in a solar system whose two temperate worlds were never meant to last forever. What we are seeing when we look at Venus is not an alien failure. It is a preview. Whether life ever lived there, we don't yet know. Whether anything of what it was is still preserved under the clouds, we don't yet know. There are missions being built to try to find out. That is where the story stands.